Let's look at Chapter 7, Lesson 4 Review. Use a pattern to complete each multiplication table, then complete the difference table. So we have 2 times 3 is going to be 6, 2 times 4 is 8. What's the difference? 2. 3 times 3 is 9, 3 times 4 is 12. What's the difference? 3. Notice the pattern. We have 1 times 6 is 6, 2 times 6 is 12, 3 times 6 is 18, 1 times 7 is 7, 2 times 7 is 14, 3 times 7 is going to be 21. Find the difference between 7 and 6. It's 1, 12 and 14 is 2, 18 and 21 is 3. As you can see, there is a pattern to this. Use the same strategies to do number 3 and number 4. Write a specific name to identify each figure, then write the number of lines of symmetry in each figure. I know that this is going to be an equilateral triangle. I can tell that because all 3 sides are the same. Going through this, I also know that it's going to have 3 lines of symmetry. Let's look at number 6. I can see that these 2 sides are parallel and congruent, and these 2 sides are parallel and congruent, which means that this is a parallelogram because it has 2 parallel sides. I can also then tell that all 4 sides are the same length, which means it's not only a parallelogram, it's also a rhombus. So the most specific term is rhombus. And I can also tell that there are 2 lines of symmetry. Let's look at number 7. I can tell that this line is parallel with the bottom line, and the left and the right lines are parallel and congruent. However, this one does not have all congruent sides, so it is just a parallelogram. Since it's a parallelogram, it has 0 sides that are going to be symmetric. Let's look at number 8. I can tell that this is going to be an isosceles triangle because there's 2 lines that are going to be congruent. I also know that there's only 1 line of symmetry. Looking at number 9, I can tell that all 4 sides are congruent, which means it's a square. And then I'm going to draw the lines of symmetry, which tells me that there's 4 lines of symmetry. This is a scalene triangle because none of the sides are equal, which means that there's 0 lines of symmetry.